Okay, it looks like we're live. So welcome back. Today I'm going to be continuing to work on Titanium Virtual Machine. It's just a virtual machine I'm working on. It's called, yeah. Anyway, so yeah. So yesterday we started working on like memory and stuff, and I want to continue that today. Okay. Something I want to do first though is actually clean this up a bit because it's kind of dirty looking. So we're gonna make a source folder and a build folder, and we'll put all the stuff in there. So actually, before I do that, let me just clean everything. And then, okay, I got rid of the test.tasm, which might not be good. Or do I still have that? Wait, okay, I guess it's still there. Ah, because I committed it, that's right. Okay, yeah, so source and build. And then I'm gonna modify the build script. So I might switch it to make in the future, but for now, not yet. So I think I can do something like source equals source. And then build equals build. And then either be in source. I have to do that. Let's not have a slash. Let's do that. Go. Okay, and then this goes into the build folder. Actually, need to become count. I think that makes sense. Yep. This is still build, but this is out. Okay, something like that. And I think that this works. Yeah. So we have two different executables that get compiled here. There's the assembler and there's the actual runtime. Alright, I think that is all I need to do. I'm not going to update the Windows one because I don't care about that right now. Build it. Build sh. Yeah, and I need to move all the files. That.c. YouTube source. Okay. And also that.h source. Okay. It's good. So now if I build it, build sh, seems to compile. And now it's like a lot cleaner. And so we have build, yeah, we have that thing. So that is extremely useful. Let's move test.tasm for source as well because gonna be, well, no. I want to move it into build. And also let me modify the .bit ignore to ignore build. It's everything in there. I can't do that. I'm gonna just ignore build itself. Okay, I think that works. I think that's how you do it. Okay, so I think I can workspace. I push that, and let me just make sure it all worked properly. Source. Okay, yeah, there's no build here. We have the build script. Okay. Looks good. So that's a lot better. So now I'll actually get to working on the code. So, yeah, so we're gonna go back to tin.c. So yesterday, if I go over here, I can work. In here, so if I run tasm, test.tasm, and then fire test.tin, it save files. So that's what we're looking at. I was not able to look at it since the last stream. So I'm gonna work on it here. That's in the it's actually in the right instruction, not read. Inst read. Let's see. No, I want inst right. I can get it. Okay, so let's see. Yeah, so it's failing. Where's it failing? No, it's in the memory instruction actually. I forgot. Yeah, I haven't looked at it since last stream, so I don't remember anything. So it's failing in here. So if we go here, you can see. It's pretty weird. It doesn't have that. Okay. DA append. Yeah, so DA append is failing. So is it because of this? Do I need to cast it to int 8b? Let's say I need to go here. Okay, what am I missing? I'm gonna change that name. It's kind of annoying with the build folder. It's fine. Tasm, test.tasm, test.tin. Yes, that didn't help. Maybe I should run it in GDB. We do have that, so let's do GDB. Time, test.tin. And then 2. Well, wait. Wait a minute. And then, okay, now let's take a look at what happens. So, and I download the stuff. Okay. Okay. Let's see. Let's just go through it. Oh, okay. So it doesn't like that. Run. I just have to run with the file name. So test. Okay. All right, then it should work. And that's where it fails. Let's run it again. And let's actually. We're gonna call run instructions. I'm gonna step into that. Let's go next. Let's go through here. Once we get into let's see. It's hard to tell what's going on. It's not very clear. Is memory. Okay, so we're in here. So let's go through this. And then let's print a.word.answer. Okay. And let's print machine memory. Print machine memory data actually. It doesn't let us access that. Let's step there. Set fault. Okay. Yes. Let me take a look actually at this DA append again. Am I using it wrong? I could try it. Let me try this. CDK, that's where I want to look. I want to look at somewhere that I use it in here. So stack, it's one of those. It's an unused stack. And then, if I do some... See, I don't remember how to do it. Second. That's not what I wanted. Nope, I created a new one. So I'm new to this. I need to remember how this stuff all works. Okay, there we go. I remember now. CDK now, and then I want to look in source and let's look at main.h. No, it's actually not defined there. It's in depths.h. Okay, let's look at that. Next I want to look at the undo stack. The stack. So yeah, that has that. So that is correct. And then comparing that to team.h in the machine, right? We don't have the machine. What's it called? We have memory here, which is this. UINT counting capacities. That's right. It's because this is a pointer and we don't want it to be a pointer. I think that's what the issue is actually. Yeah, that's probably what it is. Let's go here and let's go to the append. Oops, I spelled it wrong. And let's try that now. And this needs to be a pointer. There we go. And let's see what we can do. So let's build sh. Okay, yeah, now I see a lot of places that are broken. And I know why. So let's see, it's in here. Yeah, so now this is dot. That is, yes, that was the issue. So it's not supposed to be a pointer. I used a pointer, I set it as a pointer improperly. I should not have done that. So now we have to change all these places. I thought it was strange. I did not think about it. Let's see. Alright, I think that this is a lot of doing. Let's save that, and let's go here, edit it again. Whoops, go to sh. Oh, okay, there's one more on 513. Okay, yeah. Dot count, there we go. Build sh. Okay, cp build, and let's try to run it on x.10. And we get a stack underflow. Okay. I'm gonna get rid of this text that we print up there because that makes it kind of hard to see stuff. Right here, so let's save that. let's go here and go it again. I'm gonna have to rename that. Okay. That's fine. Okay. So here's what we get. We print the stack each iteration. So we get 8 on the stack and 0 on the stack. So why do we stack under flow? When we look at desktop tags, let's see what we have. So we push this memory, and that should push a pointer onto the stack. But the next thing we get on the stack is 0, so that's not right. So this did not push the pointer. Really it's an 8 though. Actually it might be, so that 0 is actually what that is, isn't it? And what's the 99? Alright, that's the character. Yeah, but so we should have 2 zeros. We have 2 zeros here, but that's not... Oh, that is right. Yeah, because we pushed 0 after it. Okay, so that is right. And then this consumes it all, right? We push 3, and we're trying to read. Get that. Oh, shoot, because we consume the pointer, but we don't want to pop it off. So the pointer we want to leave. That's what the issue is. So we call write. We don't want to... Well, we could just push the pointer back, I guess. I suppose. So we could call push machine pointer type like that, because we want it to be on the stack. Page. Okay. Pointer dot word and pointer dot. Okay. Build sh. Okay, let's try it now. S.tim and alright, so we make it through the whole thing. So I'm assuming it writes to the memory properly. And this pointer is really just an index in the memory array. Okay. And it stays on the stack now. So that is what I wanted. Yeah. So we wrote C to the memory. So we don't really have a way to, when we read it, it should end up on the stack. So let's just print what's on the stack in that case. I think we have print. I think that is an instruction. I build. Do I need to recompile it first? Okay. Yes, we have C on the stack when we need it. So let's see. So if I modify this to what we call read, we delete this, push 3, read, push 3, and read. So that means as a character. Then we should have 2 characters on the top of the stack. sh in expected pointer. Okay. Why did that happen? Push 0. Crossplays followed. Thank you. Appreciate that. Okay, crossplays. Why did this happen? So it's on the second one. Let's look at it. What expected? Read expected the pointer. Well, that doesn't look right. Push 3. Read, and that should consume those. So 99 is the C, the character. Oh shoot, because that yeah, because that pushes the character on there. So we need to get rid of that. Yeah, get rid of it. So we need to swap it actually. So let's just do that. We have this. I'm using Vim because that has some syntax highlighted. So before we call read, we need, or before we call this, we need to swap. Yeah, and that gets the pointer at the top. So let's try that now. Okay. And let me get rid of this debug. We have stack right here, so I can just debug that. Build sh. Right, and then it should do it properly. Okay, yeah, so it prints out C. So we can read from the memory now, character. Or so we can write anything to the memory, right? Yeah, and then it pushes that onto the stack. So actually, thinking that when we call write, I want it to consume the pointer, right? So everything is stupid, you know, like how we did that. I forgot that we have the do construction. Yeah, so we don't want to push it back. Instead, we want to modify this, and we want to just do before we call right. So we'll delete this. So that's where the pointer is. So we have the pointer there, and then I think I should still work. So I should just work. We compile it. Yeah, so it still works the same. So we duplicated the pointer, which really is just an index, but you know it's a pointer in this case. Yeah. So now we can read and write to the memory. And I would like to modify. So we have this other instruction, push stir, which pushes a string, right? To what we call the string stack. But that's not ideal. So I'm trying to move it over to this memory. So we'll have push stir, and we put a string. And what that will do is just write the entire string into the memory. Once you encounter that instruction, right? Yeah, so that's basically how it's going to work. Instead of having a whole dedicated tag for strings, and then there were some other issues that came up with that. So it's going to look like this. So basically, I can do this entirely. It's going to basically just be push 30. And you can put the string in here, however you would. And you don't need, that's all you need. So I guess it'll probably be null terminating. I could do like sized, but I don't want to do that. So I'm not going to do that. At least not for now. So it'll just have the null termination at the end by default. And then it'll push the pointer to the top of the stack. So then you can do stuff with it. Like there's built-in functions that expect a C-string pointer and stuff like that. That's how it'll work. And basically this would just expand to, not exactly expand, but basically what it's going to do is, it's going to do that whole memory thing, and then it's going to write each individual character to the memory. And that's how it'll work. And then we'll have the pointer to the start of it. And this is how we can do arrays as well. Because that's basically what the string is. It's just a character. But yeah, then we'll have access to it at the on the top of the stack. So that's how it's gonna work. So let's see. So we need to modify the push stir instruction. Not here. So let's quit out of here. And let's go to in the parser. Push stir. Let's see. What do we expect after that? We expect it to be a string. That is actually correct. So we can keep that the same. And then I don't know if we have to modify this. So let's do no, push stir. So we still have that in there. But what do we? Where else do we? Why are you here? Okay, that's kind of. And then we set the type equal to not. That's not what I want. So yeah, this is not. I want to change it. So I want to set the type equals int push stir, right? So we're gonna have that instruction. And what it's going to do is, once we encounter it, it will take this string, but we need, let's see, I think we can set the operand. We have that. Value as pointer. So we need somewhere where it's going to be stored, right? Initially. So how do I want to do that? Because we're going to have all of the strings stored in the bytecode, because they have to be, right? So I guess I'll still have a string stack like this, but it's gonna be allocated differently. Let me see. Instruction value. So how do we set these? Yeah, so we're gonna need to set the instruction value, I suppose. Just to an index, right? Instruction value dot as int equals. Hello, how you doing? How are you doing? So stack size plus plus. We don't need plus plus there. We'll do it here. We set this. But instead, the stir stack is gonna be pointers. Doing good. I am doing good as well. Stir stack size equals now size of character times stir len of instruction but head value dot text plus 1, because we need the no termination character in there as well. And we'll actually we'll save that size. So let's just set size t stir size equals len of head value dot text plus 1, and then we can use that here. stir size, and here as well. Stir size. Is that right? Yeah, so that's what we're gonna write it to. Okay. So we need to modify this so that it's a bit different, and we'll get to that. And when we're writing this, I think we do something else with the string stack. Let's see, stir stack. Let's see anywhere else that we have it. Yeah, so we have this. That is fine actually. Alright. So yeah, this thing it's gonna be different, so it's gonna be a pointer. So we don't want this max string size here. Instead it'll be like that. Try start pointer. Okay, now I need to modify the thing that's in here. We have the stir stack, right? And yeah, so we need to modify this the same way. And then we're gonna change how we actually read each of the strings. So let's see, we're gonna get some compiler errors. Okay, generate instruction. Yeah, so that is conflicting type, so we need to modify the header file. TASM.h. Yeah, so right here, we have to do the same thing. Okay, and then, okay, it does actually compile. That is kind of surprising, but I do need to modify how we're reading it, or else it's not going to work. Okay, so in here, read program from file and writing it. So right now we're doing this. We need the string length of each one, right? Actually, it looks like we're already doing that. So that might be fun. And then we just have data in, so that's like the data part. Okay. Alright, is this the best way to do that? Why can't I just, string copy? Yeah. I think I'm gonna change this. So, yeah, we don't have multi-line comment, highlighting. Forgot about that. And then what is this? So, whoops. Do we do something else here? Program size instructions. Stir stack size equals I minus 1. Uh-huh. We set the string stack size in the... Oh, we don't write it, do we? We should write that. Like at the beginning of the segment, you know? Let's try it. F1. See? Stir, hang on, how does this work? Stir stack size, 1. And then, let's see, it's a size type, right? Size of that. Size T. And, never mind, I'll do that later. And then file. So write that to the file, and then we'll have that at the start. So we can just set it to, you know, what we read from that. So we can set, we can have the machine, yes. Machine, stir stack size equals, freed from, let's see, let's grab one of the, here, just like this, sure. So we'll just read that. Let's see. If this is machine stir stack size equals freed, not instructions. Yeah, no, we want to read into actually stir stack size, but it's gonna be a pointer. So we can get rid of that. There we go. Size of size type. No, we want 1. Size of size type and final. So that should read that into there, and that should be pretty much it. So then we have the stack size, so we don't have to actually set it to this. And then when we read this, we should be able to just read right into, what is this? How? I'm trying to see how this works. Yeah, so we're reading from it. I don't like that. Let's read into machine stir stack I. So we can still have that. Machine stir stack I. And then size of character times. Can we do that actually? We don't really have that. Let's see, do we? we need like the string length of each one. So, give me 1 second. Okay, so we read the instructions. Times max. So do we write it that much? It seems like a bit of a waste. Program size, yeah. I'm trying to think. Reason. So we want to read. We want to read that. We have that, so we can make this a for loop instead. 0 y is less than machine stores that size, and then we have that plus plus, and we'll use that. That's a start. I don't think we need this though. I'm just gonna get rid of it. Let's see. I don't think we need. Well, we might need this. So if that is data n. Okay. Yeah. So that's fine. We can read this, but we don't need this part. So we have to read that into there. But how do we know how much to read? We don't need this index, I don't think. We just break. So we use the index. So don't need this. Yeah. And we shouldn't need to set this because it's already in there, so we don't need that. Size of character, and then so maybe maybe this should be size strings, you know? And then we can just append that. Because otherwise I don't know how we're gonna get the length. What if we do that? We'll come back to this. But let's go back to here. And yeah, so we push it onto the string stack. So then we're actually in the still. Yeah. So what if we write the length of it, right? So we set the stir size equals stir of machine stir stack I. And then plus 1, so we'll still have the null termination. So it'll be sized and then. Because then you can, well, I don't like that. Alright, we'll do it like that, because the size is just for reading. We'll change it later. So then we have to write the size first. Okay, so we want to write, stir size, right, 1. Size of stir, no, object size type. And then 5, write it to 5. And this needs to be a pointer. Okay, so we have the size and then the string after that. So then we can read the size first. And so we can get the size, right? We don't save the size, so that's why it's null terminated, at least for now. So yeah, we need to first of all read this into stir size equals 0, and then read into stir size of that, yeah, and then this will do stir size. Okay, and that will read it into there. Okay, first of all, we need to allocate it. Let's allocate to machine stir stack I equals malloc as a character times stir size. Okay. And then we can read into that. Yeah. So I think that's pretty much it. Let me try to compile it, and let's go through some of the errors. Okay, so stir stack size. What is it called? Just look at that's not gonna work. Stir stack. Okay, it's the whole thing, right? Okay, sure. I need to put the size. Stir stack S. Find where I do that. Okay. Size. And I think I did it up here as well. So it's like size, yeah. And then I have this loop here, so I could have just looked at that, but no, I think I have it in .c as well. Let's see, let's go through them all. Maybe not. Okay, yeah, so I guess that's it. Let's see if it compiles now. Okay. That needs to be a pointer. At 375. Makes sense. Okay, and then I use variable I. Yeah, okay, so we create a variable I in here, and we don't need it. I think we need these either, but I'm not sure. Alright, so we do use index. Okay, yeah, so we did use those, so let's put those back. Okay, and then size t and that. Okay, so stir stack size is an integer. Why is it not a size type? I think it should be, so I'm gonna pick it. Okay, then we get a lot of other places where we do that. Indent size t, so that's a lot of it. So I think what I'm gonna do is split the terminals. Let's do that. And then let's source, and let's open. No, I'm gonna build it, and then I'll just go through the errors. I would get them twice, which isn't great. So I can't scroll up. Hold on. Okay. 454. Let's go there. Whoops. I need to do that. There we go. 4. Yeah, so index. It's an int. Let's just cast it to an int. That's fine. And then where else? 376. 376. Wait. What? No, I did 476. Okay. And here's what. Alright, and then let's find this again. 399. Sure. 399. I changed that already. Huh? Oh, shoot. So that one's fine. Wait, what? Okay, because this is a size type. But then the other one's an 8. That is interesting. Okay. 312. Okay, and then 266. Whoops. Wait, what is wrong with this? It's always false. Okay. Yeah, so I guess I can get rid of this. Because it can't be less than 30. But it might break. So that's not good. Whoops. Yeah, this could be better. So let's actually just, let's check it before we decrement it. And check if it's equal to 0. So, then we have an issue because we're about to decrement and break stuff. So, okay, 288. That seems to be the last one. So I can just cast again. Okay. It seems to compile now. So let's see. I did not implement the instruction, but we did implement the read, right? So it should read any strings that we have. So let's try that. I go in here and let me modify the test outcast, right? Well actually I don't need to modify. Let's use that. Let's try to compile it. Expected close quote. Okay, that's not good. There is the close quote. So that is not it's not good at all. Let's look at probably in the like server, right? Expected close. Yeah, so right here. Whoops. Okay. Expected close single quote. Yeah, let me just search for exactly that. Close quote. Okay, so that one, and that's the only one. So I have a feeling that we're not reading the file correctly. So I can test that. Then, alright. I'll put like a space there. Did it work then? Yes. Okay, so we're reading it off by one, it seems. So let's that's a pretty big issue. So read we don't have read file. Let's see, I'm not sure how we get it. Do we just pass it here? File name, and we open the file, right? We call it preprocessor on it. Okay, so I think that's an issue with the preprocessor. So I'll create an issue for that, and then I will come back to that. Okay, preprocessor. Yeah, so I'll need to look into that. I'll probably do that off stream because that's kind of a boring thing. But yeah, we can fix it by just adding a space. That's fine. Okay, let's see if it runs. Alright, it is not. Let's hex dump and look at the. Look at this. It's actually kind of hard to tell here. What is that? I don't remember what the. Like a hex. What is that called? Yeah. That's not it. And then I can look at it. Yeah. So these are the strings. Hello world. And let's actually but it did not write the size, did it? Hello world. And then there's spaces here. So 2108. Let's look at that. So yeah, 2108. Convert. That's not right. Hang on. Oh shoot, but that's the 21 is that. So it's actually just 0A and then 0, 0. 10. What is 10? Yeah, this is the end strings. That's the last one. Okay, the 0, that is the size of it. So it's not writing the size properly. So let's look at, let's see, let's look at read. Let's see, so actually it's where we're writing it. So we write the string stack size before any of the strings, right? So we go over here to this. Okay, so before this, 0, 0, but then you write 0 here as well. Am I doing it wrong? Oh shoot, this I do that twice. Why do I do that? Is that what I have to do? Is it not one? That doesn't sound right to me. But I will try. Right, and then we'll just recompile everything. And we'll see. Let's edit. That's not in. Okay, shoot, that wrote a lot of stuff though. I feel like that's not right, because that, yeah, that'd be 4 times 4, so if I look here, it's still 0. It's a lot of stuff here. Garbage data, I think. So yeah, I don't think that's right. Okay, let me open the main page for right. Okay, pointer, size, and then, yeah, the number Oven. All right, so actually, yeah, I think I want to do it that way. So that might be the issue. I need to do that. I don't think, I don't know. We'll see. Okay, let's see. 10, let's see. Still 0 though. What is all the stuff that is running before that though? Oh, no. Let's see. So, because we open it, and the first thing we write is the string set sign, and then we start writing the strings. Yeah. So why is there a bunch of? Oh shoot! Wait. Why is there a bunch of other stuff? Is there an empty string in there? That could be it. Let me just print the size. Machine that size. Let's see what that outputs. Because I feel like it's off. Just like an empty string. That is not my size. It's not. Cancel. 1. Okay. So maybe it's not off. Yeah, so that's right. We don't write the size of data in though. So we need to do that. Size equals data. And actually I can just use size up for this since they literal, right? And that includes the null termination character. And then we can write this. Size. And then, yeah, and then here we put data in size. Size. It's going to be size of the chart. Okay. Let's see what that does here. It's got 10. Yes, I don't know what all this is. Why does it write so many of these? There's a lot written in here as well. So, and the size type, that's 8 bytes actually. I forgot about that. So that's why there's so many things here. Let's go, here's data in, right? That's started. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, is that right? Yeah, so 9. Okay, and then hello world. That's why there's so much, because I forgot the size of a size type. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 0f. Is that I don't remember what that is. 15. Okay. Yeah. 15. Okay, yeah, so with the null termination character and the new line, that's right. Okay, yeah, so that is right there. So all those are right. I still don't know what all the stuff before it is, though. Oh, yeah, that's the size of it. The size of the step. Okay, I am stupid. Okay. So it does actually all make sense. I just forgot the size of things. And yeah, we have to make sure that it's that size always, because it could go over that. So you can't just write it if it's small enough, like write it as an int 8, because then we don't know how much to read from it. Okay, so that should work loading it. So let me run that. Let's put out of this, and let's try to hit a cycle, which is interesting. So let's take it, and let's break it, and we'll run with and let's see what happens. So next, and when we run, okay, what is this? Let's run again. Hey. so this is, it's fairly in here. Let's see what point. Okay. Okay, so it's in the string compare. It's I minus 1. It's going to be 0. So not just I. Yeah. Yeah, okay. Because the I minus 1 is from the old way that we do it. So that's what the issue is. I am quite sure. Because it was underflowing, right? And then it was very much on. So let's run, and it still say false. Okay. Here. But I need to actually run with, 10. Yes. Okay. Thanks. Instead, is it in the same place? Uh-huh. Okay, so it still isn't like that. Maybe I should output what that is. Let's run it again. Start over. Alright, so let's look print machine sir stack pi. Cannot access memory. Wait, did I not allocate it? No, I did allocate it. Why can't it access it? Let's put it to size. 15, so that's right. Alright, so that's what the issue is. Also, string compare probably would fail. The string is too small, so I'll need to do string string. Yeah. Read that. Read this size of character. Stir size. Why does that not work? Oh, shoot. I don't think that's supposed to be a pointer like that. Then it becomes a double pointer. Still say false. Okay. Alright, let's what? Machine server stack pi. Okay, so we got that property. Oh shoot, yeah, if we have the string tag size, we don't need the end. So that, this actually fails because now we're trying to read that. Yeah. Okay. Yeah, we don't need the data inside because we just get the size of it. So we can get rid of that entirely. This one. Yeah, and then we don't need this check at all either. Okay. Yeah, that actually makes it good. So we go here, load it again. Data and size. Yeah, I need to get rid of that. There we go. Good message. Okay. And in here, so if we compile it and we look at test.2, was actually okay, then we have this is the size of the stack, and then this is the size of the first string. This is the actual string. And then what is this? So what comes after? Then it's like instructions and stuff. So stuff that not really readable. Let's try to run it. Okay, so it did not fail. So I'm assuming it read the string properly. To the string stack. So we still have the string stack. But then we're going to write it into the memory. What do we want to do? Right, I suppose. So then that's how you do that. Yeah, I think we better do that. Okay. Yeah, now it's clean. Okay. So I'm new to Tmux, so stop. So now we wrote that. And then when we encounter the int push stir, I don't want to do this anymore. Which I wonder why that did not. Why did that trigger? Because that should have push stir. Yeah, why does it not? Yeah, it equals the current stack size. So then we'll be able to get it. So we'll basically write that entire string to the memory, and then we can then we'll push it onto the stack as well, the pointer to. Yeah, but why did it not encounter that instruction? Yeah, because it should have assumed false. Push straight. Okay, let's try that. So we need to basically we need to do what we do with this memory, right? So I'll just copy this whole thing and then modify it. Let's add these here. Alright. So basically, a.type. So we pop it off, and that is we don't need to pop it because we have the operand, so we don't need this. Yeah, we're not going to pop anything off. So the operand is the index in the string stack, which we're going to push. So let's get the index equals machine instruction ip.value.asd. Tmux looking good. Yes, indeed. Yes, indeed. I did not install any plugins yet, because I want to get used to using it like vanilla Tmux before I start installing plugins and stuff like that. Just because, you know. Yeah, probably the first one I'll install is the Vim keybinds one, because that would be nice. So we don't have this anymore. But that's the index, so then the string equals machine stack index. So we have the string, so we can iterate we're gonna need the size though. Yeah, so the stir size equals stir machine stir stack. Just have stir. Okay, so that's the string size, and we'll iterate over the string size. And we'll append it to memory. So we want +1 because we want the no termination character. So into there we will append that's not what we want. We don't want to do append. We want to do the same thing that we do with the right. Let's get these right. Yeah, so we want to do this basically. Then copy into the memory at the current index. Add this to your tmux config. Set -g base index 1. That will make the first window the number 1. But I like it as 0. I guess 1 probably makes sense doing it there, but okay, yeah, I'll save that, and then I will do that after the stream. Because actually that makes sense with like reaching over, not reaching over 0. So yes, thank you for that. Get some right. Yeah, more uncomfortable. Yeah. I see what you said. Okay, then copy into plus the index or the size of that. Is that what I want? This machine memory dot, and then copy the whole string into there. And then we want to iterate the character. So actually, since we're just doing it one character at a time, we can just set the set up this machine memory dot data. Actually, we do want to append, don't we? Because yeah, we want to do the append. That's what we want. Of stir up. Yeah. Okay. So we append that, and then we have this. So this is the index that we have. Yeah, so we don't want to subtract that, but we want to subtract the stir signs. And then that is the index of the start of the string. Okay. We're done as int. Okay, I think that works. Make sure it compiles. It does not. I undeclared. This is IP. Okay, then it compiles. Hopefully it works. Let me try to compile. I gotta get rid of that for a second. Okay, so it doesn't say fault. Let's see. I could use GDB to sort of go through the whole thing and see what happens. Let's run tire GDB and run test.tim. Yes. You are making a VM to run Gentoo? That is what you were doing? I've never used Gentoo. Okay. Next. Break main. Run. Next. Okay, run instructions. Let's step through this and let's see what happens. So, just end. Okay, was it supposed to? Let me try that again. Next. Next. Step. 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 I don't want to step into one of the built-in functions. Okay, so it seems to have just skipped it. So it's not calling it. Let's print IP. Actually, let's run it again. And let's print with the print. Oh shoot, because I'm in an entry point, right? Machine entry is 1. Print machine stack size, is that what it is? 0. What's program size? Print machine program size 1. Okay. Yeah, so the entry point, I guess we have to set that, right? So we can modify it. Let's do name and then entry point name. Then that should be the whole thing, right? 10. Okay. We enable. Whoops. And run. 10. Yes. Okay, let's go through it. Step here. Print machine. Entry point is 1. Print machine program size is 3. Okay, so we're gonna actually get some stuff here. And are they all? No. Okay, that didn't work. Whether this is the most base stream on Twitch right now. Is it true? That depends. Yeah, I am using Arch Linux, which is pretty based, right? And Tmux as well. Yeah, I'm not using Vim anymore. I'm using my own text editor. I used to use Vim, which is also based. Base levels be increasing pretty fast. Yeah, I don't know what else is base though. Yeah, that's pretty much the end of the base city. What is this? Oh, push stir. It doesn't set it too bad. I don't know why it did that. Okay. So, yes, this is my text editor. It is, it looks like it, but it's not it. It's one that I built from scratch. Okay, yeah, so I think that in the, yeah, thank you for following, by the way. Okay, not really, Kano. Let's see. Wait, where did you post that? We should have the index. Push str. So why does it not set the instruction type? It should be. Names of code save. Okay. Let me do this. Okay. Let's keep it. Alright. Set that. We don't. Doesn't set the instant push stir. Why does it do that? This sets it. Let's see. There's someone here. Why not have the type in here? Let's push pointer and push to it. So you have that. Extremely based. Based. Don't know why. That's what happened. Do I change somewhere else? Here's program. So let's look at the program. Insert that. Okay. Then the program, yes, the program is just a list of instructions. So I don't know why it's like this, but it is. Okay. So that should be fine. Equals value. Yeah, this is some old code that I wrote a few months ago. So I don't remember it all, and it's not very good. Set that. Why does this get set to nope as well? Did we get, well, no, we do get to this point because we appended the string stack. So, do I break or something? What is this about? Fix this? But I got the, what the heck? I didn't say what I have to fix. Okay. I need the data type. Yeah, I probably do. Okay, so instruction data type. So I do probably need to do that. That should be it's gonna be a switch statement as well. Push program. Yeah, so I don't know why it dev push stir. Should be setting it for that. Okay. It's not seem to be. Yes, we do make it in. What is the one? What else are we putting in? I don't know. So I added a print statement somewhere else. Was it in here? It was not. What's that? I don't know. Sure, I think it was it. The inst push stir. That's all it is. No. Yeah, it's when we're compiling actually, so it's not going to be in here. Yeah, I don't remember where I put it. After that, though, so it's gotta be in here. Unless it's in the right program. Fine. That's what it is, actually. Yeah. Okay, there we go. I'm gonna get rid of that. Anyway. Okay, so we do get to the inst push stir. So that is a thing. They're all no constructions. Wait on and no, I need to run with okay, sector. Alright, and then let's print machine stack. Machine stack 0. Machine stack. So that is no, but I don't want the stack. I want the instructions. Next mention pod. Instructions 0. Okay, as char. Why do we have mod f? Machine instructions 1. These do not seem right to me. So we'll do this actually. Okay. IP. Machine instructions 5p. And the type is that, so that's not right. Well, it's not just for C, but it is a debug. And it does work with C, so I think that's what I'm using it for here. But you can use it with like assembly and well, I think it really just depends on like the language or whatever, the compiler that you have. Not so much GDB. Like it just has to compile to the right symbols, right? I don't know how it works there. Okay, so that's not good. So it's not no constructions, but it is it's not the right thing either. I'll try to explain. So it's like out of bounds. So why does that happen? It's gotta be, well, it's probably reading. I'll probably read it on it. Read. Let's look at that. Did I mess it up here? It seems to be, let's see. This isn't right anymore because I don't want to seek to the end. I think I want to seek to index, right? Oh no, that's the, oh shoot, but that's the length after that. Oh yeah, that goes to the end and then the index, yeah. I see. But then length needs to be equals minus tel 5. So that would be the correct length, right? And this is supposed to be what? The endpoint is just a single node. So let's try that again. Try to compile this. And let's compile this. And let's run a hex on this. Hex edit. Okay, so we have this. And now what is all this? Hard to tell. Kano is completed? No. I'm working on, well, I worked on the virtual machine some time ago. And, well, it was like 3 months ago now when I stopped working on it. And I wanted to get back to it. And then I was working on the scripting language for Kano. And I decided I think it'd be cool if it compiled to the bytecode of this virtual machine, so it'd be interpreted by that. So that's what I'm doing. So I'm getting the virtual machine to a quote-unquote completed point, and then I'm going to write the scripting language for Kano in the bytecode, essentially. So that's sort of the goal. So I'm working on this sort of as an extension of Kano. But yeah, there's more stuff for Kano as well. Like there's some bug faces that I need to do and a lot of other stuff. Yeah. So I'm working on this for Kano as well. Also, I like to work on other projects sometimes as well. Okay. Based. Okay. Enable. eBay. And then run test that. Okay, try this again. Step. Okay, and let's print machine instructions. No, print machine, instructions. I don't remember how to print the first however many elements. It's no. Okay. Instructions, 0. Two. Uh-huh. Machine. Entry. Machine program size is 5. Okay, that's interesting. It's actually, I think we can display this. Okay, I need to display. And then we'll be able to see it as we go through. Right? That's the thing. Next. Okay. Type equals inst. No. Type equals that. So what? Why? Where does that come from? Yeah, like it's all the way out of bounds, or it's a no instruction. Yeah, but none of the proper instructions. So let's get out of this. Okay, so something is very wrong. So we go to the end of the file, hit the line. We do this. Maybe I should have stepped through this. Oh shoot, but when we write it, we need to write it properly. That is important to do. Okay, now it's a lot shorter because we weren't writing all those extra bits of data. I don't have bits of data. Able this, yes. And I'll go through the reprogram as well if this does not work properly. Print machine program size 3. Okay, so that's closer. Display machine instructions IP. Okay, so that's not right. Yeah, okay, so that didn't work. Let's run it again. Let's step into the read program. And we'll see what we're reading. So this should read the strings properly. I think that works fine. Machine serve stack I. Oh yeah, we haven't read into it yet. So print machine serve stack I. Okay, there we go. So we read that and that was proper. Instructions, we just allocate them. Then we seek that. Print length. Actually, it's existing length is 135. Okay. Yeah. Then there. Still 135. Why is that? What was index? Index was 0. Oh shoot, because we don't set index. I want to set index. I want to go here and want to set index equals until 5. So then we have the position after. So I'll need to update that. So that's at least part of the problem. Let's print. Yes, the entry point is going to be off. It's not correct. It is 1 because that is the stack size at the beginning. Build a better send and go. Very cool. I would definitely like to take a look at that once you implement it. How's it going to be better? Like, what specifically do you have in mind to make it better? It's 10. Okay. Break menu. Really? Base to B said. That gave me a good idea. Okay, I see. So just the name, B said. Okay, one with testing. Good name. It's a good name. Okay, so let's go through this now and make sure it works properly. So we read that. And this should still be all fine. And then print index. That's 31. Okay, so that sounds about right. Print the length. So it should be less than 135. Yep, okay. Print machine entry point, which is 1. So it's still 1. But that actually is, that's still right. So instructions 0. Instant, okay. Instructions 1. Okay, that actually looks right. Push stir, because that is what it's supposed to be. So we set the program size equal to length. Okay. The instruction equal to instruction. Why would the program size equal length? 3. Wait, what? The length is 3. Oh, shoot, because we set it after we read everything. I see. Yeah, okay, that makes sense. That makes sense to me. We reallocate the instructions to that. Yeah, okay, so it's the right size, and then we don't really check if it's null or anything, that's fine. Okay, so now the run instructions should be correct. Let's display machine instructions IP. Alright, so no, so that is fine, because that is like the label. So we continue. And then push serve. Okay, so we actually go in here, and I want to see if this works properly. So index, let's print index. It should just be 0. Okay. And then print stir is hello world. Okay, that's right. Print stir size, that's gonna be 15. So we append to the memory how many times? Let's print machine memory. Okay, yeah, so we're just gonna write it. So let's display machine memory. Let's see. Hello. Yeah, so it's just it's running the whole string to memory. And then it should print the word. That should be a pointer, right? Well no, it's not a pointer, it is the index. Yeah, okay, I see. So push the index, and then we can read from the memory. But really we need the pointer. So we need the pointer to the pointer to what is at the index. How do we do that? Because then we can actually do stuff. Like we can use it as a string, you know, like calling built-in functions and stuff. So let's go here. Let's see. So we have this VRAM. Pointer. So we get that word that has pointer. Then data. We want reference. So pointer is that. So yeah, we just take the pointer. So we can use that. So we can use reference to get the pointer to that. But how are we gonna? The push, yeah, the push stir should really push the pointer, the actual pointer. So let's look at that. Push stir. Not the index and memory. Yes, let's do that then. So the pointer is gonna be it's gonna be a pointer type. It's really weird, that's fine. As pointer machine memory data. Machine memory not data. How do I do that? Plus the count. Machine memory dot count minus serve size. So that should be the pointer to the start. So now, note to set through it in GDB again. Let's compile. So compile the thing and use GDB. Fine. This thing and run with that file. Next step. Alright, so we go through the make instruction. Then push pointer. Okay. And we have the stir here. So what I want to do is look at the word after. Print word is that, but can I cast it to a char star? If I do that, then there we go. So it is it did write that. So we have the pointer to it, and then we can use that for all our stuff. Okay. Yes, that's just unique to the push stir because of how we would handle that. But then we can call the built-in function. So I think we have some native. So for example, we've got string compare. So we could do that. So string compare, it just needs two strings. So what we can do is we can modify this file as a file, and we could push through that. Push through yellow, and it should we call native which one is it? 90, sure. 90, and I think that is all that it needs. We can exit there. And it's save faults. Okay. Let me see. So 93 string compare. Yeah, it just needs two. So let's look at the actual thing. Let's see what it does. So native string. Okay, we get string 1. So we pop it as pointer. Cast it to a char star. Uh-huh. So why does it not work? Because they should both be on the stack. I guess we can use GDB again. It's quite useful. Okay. Next step. So let's put machine programs on it. Take a look at that. 5. Okay. So we go here. And we have the note, and then we have push stir. Stir. If that's right. Okay, we push the whole string, and we do that. Go here. And then stir is yellow words, that's right. Okay, so we get through there. And then we get here and we go to string compare, which is this one. We just skipped over it. Okay, that's not good. Is it because of that trying to do 9 or something? I don't know why it would do that. Oh yeah, there is an issue with it reading 5. Okay, that must be what it was. So let's print here. So we can see what's on the top of the stack. 0. So alright. Why is it 0? Okay. We check if it equals 0. So that's kind of interesting. Alright. So if it is correct, then it equals 1. That's why that's that. Okay. So what we can do is make them equal, and it should be 1. 1. There we go. Okay, so yeah, we can actually do that. And that's yeah, it's a bit better that way. So we have an actual memory that we write to, essentially, is how it works. Yeah, I'll probably revise it some more. But for now, that is quite useful. Yes. Okay, so I need to get rid of some of the, well, so what I want to do actually is, actually I removed that, so I don't want to do that. Yeah, so this native stuff, I tried to make it, like, correspond with, Linux syscalls and stuff, and then that made it very large like this, so I don't know how I'm going to do that. I might change it. But also, something that we need to, that should be kept in mind is that we have native write, and then in the it's actually in the test, we have this defs standard defs dot hash, right? So that's the header file. We have write and read, and now those are keywords, so we need to rename this. Let's do n write and n read. That's gonna break some stuff, but it's okay. Most of the tests are gonna be broken, so I'll need to revise them. I think it's okay. And then something else. So let's go here. We can try out the write as well. So I think that is 1. So we can try to write it. So what does that expect exactly? We go there. So string. So that is, what is a string? So that's like the file descriptor. So we want 1 for that. So that's going to be on the top. So we want to push 1. So that's the write. Native 1 is write. Syscall. It's the syscall. The string would be there, and then the length is going to be this. Okay, it just gets the length because it's all null terminated, so that's fine. So just push the file descriptor, which in this case is 1. Okay, so let's try that thing. I think that'll work. It's about 10, and it should output it. Hello world. Okay, it did work. We have that printer, that's why I forgot that. To run it though, not that. Yes, hello world. So that's pretty cool. Yeah. So this is so basically we write a string to the memory, the runtime memory of the program, and then we, well, yeah. So whenever we call this, it writes that to the memory, and we can access it in the memory. So we have a few different ways to access it if we wanted to. We could call read, where we have a read instruction. Here. And that takes the size. Well, actually, it doesn't take the size, I guess. I should make it take the size instead of the. Right now, I have it the type that we're trying to read, but that's not exactly good. If we just send the size, so if we want to read 8 bytes from for a 64-bit integer, then we do that. Or if we want to read the size of a string, we could just push the size of the string. So that's probably a good idea. Let me see. We do have native strlen as well. So I want to see if I just want to make sure they all work. So strlen is 94. Okay. Let's print what's on the top. Okay. That's not good. Oh, shoot. 14. That is the size. I don't know what this is all about, though. What the heck? What happened? What? Did it change the language? Why would this happen? Let me exit out of that. Exit. Okay. That was kind of weird. Yeah, no, it's not like this. Okay. I'm not sure what happened there. Let's start it. Okay, so that does work, so that's good. I am happy with that. And before, the way the push string worked, it was based on the order of it instead of, like, basically, you could push string here, and then when you try to get the string, you have to know the order. So if you import a separate file, if that has a push string, then that would be the first one, and this one would not be, even though it would look like it is from your perspective. But now it's just pushes it on the stack based on this, so that makes a lot of sense. So I think we have an inst get serve, which we don't want anymore. It's just a serve unused. Yeah, it's not used anymore. So I'm going to need to change a lot of stuff. Yeah. Okay. Yes, we do have false. I just want to make sure. Sometimes I don't use booleans. Okay. So yeah, so don't get this right anymore, that's fine. We have casting, right? So I don't know what it's called. It's like yeah, we have like into code or something like that. Into yeah, it's this. So I hear so we need casting for everything, right? So we want to be able to cast to in pointers and things like that. Well, actually, the referencing is cast to that. So we just reference it as a pointer of itself. So, I'm trying to think. Yeah, if we just have cast to character, then we have that. We don't have the right. We just have float in and int to float. We're actually able to cast it to character as well. Like basically to cast to anything, because I'm going to build a program range on top of it, so we're going to be able to cast in that language. Yes, this is just comparing that's like stuff on the stack. Okay, so I'm trying to think now how it's going to be used. I need to revise a lot of the examples because then they're not going to work. So if I do build, I build test, right? What is it? Test, yeah. Test. Is that not how you do it? If it's T, then it goes there. Oh shoot. Yeah, this doesn't work anymore because we don't have this. We need dot slash source. Big slash has it. Then that should work. No. Okay, so it doesn't work anymore. We do a test, so we can just so I think that like the Fibonacci one should say there's nothing with strings. Slash has it. Okay. Build slash tire. Tin. Expected int. Okay, so it did not work. So why would it fail? Expected int. Oh shoot, because we do push string here. We have. Let's see. Oh shoot, because right, it's now in right. that might be the only issue, but we also do get stir, so that's not good. So we're gonna actually probably set up the stir. Ooh, that's interesting. That's obviously not the right numbers. That is not the fitting number. So let's see. Yeah, I didn't realize that before. It is. So what's the issue here? History. Native blank. Integer should still work. That just converts an integer to that. This is, oh shoot, because the push through, it pushes that. That's not even gonna work. Yeah, so that breaks stuff as well because it pushes stuff to the stack now. I didn't do that before. But so is this though. Yeah, it's not fast. Okay, what else would be different? Also, yeah, okay. There's no highlighting in this one. It still looks fine though with the default highlighting because the numbers aren't highlighted. Okay, in swap, zero. Yeah, I need to modify the index swap as well because right now it's like based on absolute position, but it's really based on where you're at. So like, if the stack is 1, 2, 3, like this, so this is the top, and you do in swap 0, it should swap the top 2, so like that. But right now, what it does is it takes this one, puts it here, so this becomes 3, and this becomes 1. Yeah, so that's not ideal because obviously it's gonna be hard to know the absolute position. So I'm going to change that. So this is gonna break anyway. So should I even work on get stirred? This shouldn't be what's breaking, but I'm gonna do this anyway. Stir 1 and right into stir that. Okay, so that's fine. So 0. Yeah, so I don't want to get rid of all of those and make sure that's not where any of the issues. Alright, 48. Okay, so I need to add like a new one. Yeah, that's what the issue. So it's an issue with reading the file. Huh. Okay, so that's obviously very much not right. I feel like it might be like a pointer or something. This is interesting. Hang on. So give me 1 second. I will be. Okay, I am back. Sorry about that. Yeah, can't even remember what this said. My bad. Okay. So yeah, that's not gonna work, and it's gonna break even more. So I'm gonna update the index swap, and index dupe as well, so that can work. Yeah, I'm just gonna update it so it's not based on that. So let's move this over a little, like that. Okay, so instead of this, we want the machine stack size. I think that's what it is. Minus that. So like minus 0 would be the top. Yeah, that's what we want. I think that's what we want basically. And then in swap stir, we don't need that anymore because that was an old thing. So this is unusable, so I'm just gonna say false and unused. I'll get rid of it all later. It's just gonna cause like compilation issues to get rid of it now. And let's find in yeah, this one as well. So it's gonna be some kind of machine. Stack size minus that. Okay. This one as well is assert false and unused. Okay. I think that's it. So let's build this. And let's modify the SI and we'll try it out. So let's do push 5, push 10, push 15, and let's do in swap to 0. So that should swap the top two. So it should be 15 and 10. And then we print. That should print it all. Hasn't. Okay, and I think that's an issue with the reading again. Yeah, that's an issue with the preprocessor because it runs it through that and then it messes it up. So I need to modify that. Select him, and we get 0, 10, 5. Why is it 0? Huh. 0, 10, 5. That's not good. What if I do 1? Okay, so yeah, we need to do use some different here. So the issue, we need to do that -1. Or no, +1. So why is that? Probably the way that I had the fun set. Well, let me try that. And swap right here. Okay, let's see. Let's rebuild it. I'm messing up what? Stack? How did that happen? Size, there we go. Okay, build.sh. That's not Hasm. And where do we get that? 0. Huh. Okay, that doesn't work. Oh shoot, do we have to do -1? Because we're subtracting it. Yeah. Is that right? I don't know about that. Let me think. So, I'm not even sure how this works. What? You do? Next. Okay, so push index outward. Not that. So where do we pop it off? Oh, because that's the deep one. Okay. So index so if we take the stack size, maybe I should print it. Let's try that actually. Index. Let's do the swap one because that'll be print that. %2. So that'll be the stack size. Actually, I think it's just an int. And then we'll have the instruction, and then we'll subtract them. So machine stack size, machine instruction IP value as int, and then yeah, and then we'll subtract machine stack size minus machine instructions IP value as int. Okay, we'll see what it says. So let's modify Hasm, so we have in swap 0. Okay, so everything. Let's exit. Okay, Hasm, that's not Hasm. In, so we get index on 0. Okay. Because I do that, that's one. Well, actually, I don't know if that's good. 64T, so we need to do that. There we go. Okay, now it's good. It's not 2. Okay, so we get, this is, okay, we got 3, 0, and 3. So 3 is the top of the stack. But we have to do -1, right? So we want this minus 1. Yeah. That. Yeah. Okay, to account for that. So that should fix it then. Okay, yeah, so then it works. We need that with the index dupe as well. Okay. So let me test the index dupe. So this breaks like pretty much all of our tests. So in dupe zeros, that should yeah. So then we don't really need just the dupe instruction. Because this pretty much replaces it. Because this should duplicate 15 on the top. So yeah. So we'll need one extra thing. That's not Tim. 15, 15, yeah. So that worked. And that's better, because then it's more of a relative thing. And it's a lot easier to work. So I am, yeah, happy about that. So yeah, I see. So I'm trying to think, like, what else is neat? Actually, I should commit stuff because I haven't committed at all. I've actually done a lot. So which there. I guess it wasn't that much. A lot of it was deletions. Okay. Yeah, it's good. So I'm trying to think like what else we'll need for the language. So I should probably write some stuff in the assembly. That would be written. So let's whoops. I want and then let's modify some of these. Or let's get some of these. So let's look at exit. This should still no, this is the stir. If we do that, then it should work. Native right. Did the stream down? Sorry, it looks like it died. I disconnected from the chat. Okay. Instrument reads, we set that, we import this. Alright, so let's try that actually. Slash chasm. Exit chasm. Slash tire exit test. Why is it print test? Let's echo that. 69. Okay, so that actually works. Okay, BizBuzz will not work. Yeah, because we want to push it when so I'm gonna need to modify that. I don't want to do that right now. So let's see what else. Hello world, we can modify that one and get that one working at least. Let's see. Okay, so we push stir. We don't need to get stirred. And we need to use native right now. And that's pretty much it. So that's what hello world would look like. And yeah, so you could think like in the actual language, you'd have like a main function, right? So this could probably even have a main label and then an entry point. Okay. But yeah, so we'd have like a main function. I don't know if it would look exactly like that because that's pretty much just C syntax. Probably actually the language is gonna be like a scripting language, so it's gonna look more like func name. So that's like the start, and then you have end, right? Or end func maybe. Something like that, you know? That kind of thing. I'll think of the syntax later. And then you would have like write hello world. And that would compile to something like this, you know? Where you have you call this syscall, you push standard out and you push the string. Things like that. So that's sort of how it would look, you know? Yeah. Even though this isn't like a whole lot simpler than this. But as it gets more complex, obviously, it gets simpler. But yeah, that's sort of the idea. I think that will work as well. So let's make sure though. And hello world. Okay, so that works now. Leave the test.test. Why don't I have this? Let's get rid of that. Okay. Alright, so like string reverse, I think we had that. Yeah, so we did all this stuff, none of it's gonna work it. Because of how it works. Yeah, so I need to change it now. Because instead we would need to do it based on the index. Shoot, so we need the index as well. It's gonna be a bit complicated. I'll think about that. But basically, yeah, we'd modify the memory. Like an array, essentially. Okay, what else? Test. Okay, so what is that? Do those work? It's if I change the end right, it should all still work. Except for the push still. Yeah, we need to just basically move it down there. Okay. Let's try that. Save fault. Okay. Did I do something wrong? So I would add them into story. Push that. And right. Push through that. Yeah, I don't think that's me. So let me try running it with GBB. Right. And let's see. So let's and run with just run. I don't know if it didn't do that. So there we go. Let's see. M colored X followed. 250th follower. Thank you. Appreciate that. Very cool. The goal was met. Okay. That did not work. That was loud. Okay. We need to run with, I don't remember what it was. It was, yeah, negative. Okay. So, negative. Okay, yes. Let's do that. Let's step in here. So let's print the machine program size. Let's go. Okay, so it's not. Let's go through. So the first one's probably going to be, okay, I guess it's push. Yeah, because you don't have push. So push that. So let's print the machine stack, and we can see the top few. So we have negative 35 and negative 34. Okay, so add. So that should have worked. Stack. Stack size. Still negative 34. Alright, so this must be where it's failing, right? And so we'll be doing native right? No. It should be calling native right. So what is this? Let me print the machine instruction. It is native, and it's 99. Okay, yeah, so that's converting to that. Oh, but it seems to have skipped over. Oh shoot, yeah, because we call it here. So that's going to call it call number 99. Yeah, okay. So we go through and we push again. So what is this? Print machine functions ID. So this is a push and it's pushing 1. Yeah, because we're about to print it. So that's what we assume. Print, and it's gonna didn't do anything. Interesting. Push string, yes, that pushes the string. I wonder where it's set faults at. Push 1, and we try to print it again. And it prints it. There was no save fault. The save fault's here. What? Huh. Okay, why? Okay, why is that thing? Let's print that. Let's try running that. Oh shoot, wait. Are we running the wrong thing? Because it's supposed to be, oh shoot, we were running the wrong. We're running the wrong file. We're supposed to run the TIM file. That's, okay, that's what the issue was. We ran it in there because we called it properly. Okay. So it was moving. Yeah. That's what the issue was. Oh, that was kind of stupid, but okay. So it does work. Let me just make sure. And then call tire on the TIM file. Okay, so it does work. Okay. So we have that. We have some other stuff. Print int. I don't know that. That's probably not gonna work. Well, maybe. Where's that? Perfect. You can just push stir, push it as a string, and then do that, and end, right? I'll print in, and that is actually in here, so that's not going to work actually. The standard dot flash. Let's see, yeah, a lot of stuff in here is print int. It doesn't seem to work. Oh, we get print int, yeah, okay. Print int, okay. Call convert, okay, so we need convert. So it does a lot of stuff. We don't need any index file. Looks like it might work. All right, let's try it next. Let's as in print int. Okay. Probably not gonna work. Oh, okay, it did actually still work. All right, that's actually pretty cool. I was not expecting it to work. Okay. That works. That's cool. However, yes, this is just more standard library stuff. I don't know if it's gonna work. This is type. Okay. Is that right? That is actually right. Yes. Let's pull up a calculator on the second monitor. Okay. That's cool then. So I guess a lot of that stuff still works. All right. That's pretty cool. So I don't know that changed very much. What did I do? Oh, okay, take the effect. I guess there's not. So there's nothing to commit. I thought I changed something, but I guess I did not. Okay. So what else? What else do we need to do for the link? So I'm gonna be probably just I'm gonna be like planning out how the link is gonna look, like the syntax and everything like that, and then think about what I'll need to implement to get it to work. But right now, like we have the structure for quite a few things, like so it's gonna be it's Kano script still. And then later on, I'll build a non-scripting language on top of this as well, called Titanium, because that's sort of what the plan has been, but I haven't built that yet. So we're building this, so 2 on top of this. So Kano script, right? So Kano, call it that. So other than before, it'll be something like func or function, something like that. Main. We need that. Yeah, for the arguments. So we'll have that. We'll have end function. Just gonna look like that. And the indentation won't matter, probably. Yeah, it shouldn't have to matter. So we can use loops for labels. So we have the functionality for loops from the labels. So we can do that. And we have yes, like right, hello world. So we can obviously expand that. So that is pretty much the simplest thing. But it'd be something like that. Right. And then if statements, we can do those because we have ways to compare different values. It's like if yeah, we can define variables as well, and we just store them on the stack, and we store the location on the stack. Right. Just trying to think of all the different ways to think about it. We have most of the things that we need. That's cool. Yes. And then yeah, so I'm gonna use this and build out like a whole language that has most stuff that you need, similar to like Lua, that kind of thing. And then I'll integrate it into Kano once it's pretty much all done, quote unquote. Yeah, what else do we need? So we probably be something like this. Let x equals 15, y equals 20, right? And then well, you won't be able to just write directly, so we probably have like a built-in function print, which would work like printf, that kind of thing, in which it would convert the integers to strings and stuff. Lua, but butter, yes. Butter, yes. No. But yeah, obviously arrays are going to be 0 indexed, so it'll be better than Lua. That's a joke, by the way. Not the index part. But yeah, so that, we'd be able to probably do this. I don't know. I'll need to think about how it would work. But something like that. We can also call, into stir on x or something like that. And that'd be the argument, you know? And you would probably do, this would probably be return something? Or would it just, yeah, it would return. So let, stir. I don't know if we're going to have data types. Do I want it to be dynamically typed? I don't know. I kind of like static typing, even in scripting languages. Yeah, I'll probably actually have that. It's like might not look exactly like something like this, and string, that kind of thing. Because that's pretty useful. Or, like the actual static type. And it's going to be compiled, so, compiled to the bytecode, but it's still compiled. Then you could write it straight like that, yeah. Mm-hmm. And what else? So I also have the preprocessor, which does need some work, as I have noticed today. And that, I'll probably use that in here as well. So like you would, to import separate ones, you could import, another file dot container, that kind of thing. And it would just basically expand here, above it. So you can call functions from that and things like that. But then also, I'd like a way to, not at compile time, but at runtime, import files like that. So the thing, make it, no, well, the thing is, it's compiled to a bytecode, and the bytecode is interpreted. So it's not like compiled to machine code or anything like that. Like that's what the virtual machine is. The virtual machine interprets the bytecode. So it's sort of like, it's still interpreted. It's like how, Python has that. Python has a virtual machine where that happens at runtime, And this is going to work in the same way, where you'll run it, and it will compile to the bytecode, and then it will go through and interpret it. So it's sort of interpreted and compiled anyway. But there's some benefits that come with having it be compiled to the bytecode. It's not like C compiled to that or anything. Okay. But yeah, so static typing, I think I would like that. Okay. Yeah, you can do this, but I would like a way, to where you can have like if x equals 15 or whatever. So obviously this is just an example. And then end it, that kind of thing. Yeah, it's like Java. And also, like Java is known for that, but Python has a Python virtual machine as well, and its own bytecode and stuff like that. Yeah, like most scripting languages do. Like there's sort of two ways you could go about that with an interpreted language. You could interpret directly from like the syntax tree, right? And that's generally going to be slower. Or you could compile it to the bytecode first, so it's going to take longer to start, but then once it gets going, it's going to be faster. That kind of thing. If that makes sense. Yeah, but so I want this, and then you could call like execute an external function or an external thing. So then that way, I'm thinking like in terms of hardly depending on Linux APIs. There's a few that it depends on. But I'm gonna try to get it working on Windows. Like I have it can compile, or at least it was able to compile in Windows, but it wasn't working properly. But yeah, like there is some native functions that would not work. Like the write is a native function, so I need to figure that out to get it working on Windows and Mac OS and stuff. But I would like it to be cross-platform. And right now it's not quite. It's pretty close though. Like there's not a whole lot of Linux specific API things. Yeah, more useful for the cross-platform. Yeah. That is the goal. Okay, yeah, so this I was thinking, let me think. So basically if there's certain conditions. So there was something specific that I was yeah. So like if imagine this is for Kano, right? If not syntax, but if language equals C, then it would call it would interpret C.Kano, that kind of thing. And this would be for the syntax highlighting, right? And then elif or else if I can like that better, it doesn't matter. Elif language equals Python, then execute Python.Kano, that kind of thing, basically. I like that. So there's like a way to you could import a file at runtime or at compile time or at runtime, basically, is what I think, but then this way, this would be for syntax highlighting, right? So it would syntax highlighting, auto indentation, all that stuff would be handled in here. That's what I think. Yeah, if that makes any sense. So this is sort of what I'm gonna change some stuff, but it's sort of what the language is gonna look like. Yeah, so I should be able to start working on that soon. There's just a few more things I need to iron out in the virtual machine. And then I'll start working on it. And if there's a certain feature that I need, then I can just implement it, right? So that'd be pretty cool. Yeah. So that's pretty much it. I'll probably save this. Yeah, just for like to for reference, right? Let's see. Okay. Yeah, so that's gonna be probably about it for the stream today. Okay. Yeah, so I need to also improve this, like the readme. It's not very good. Also, it's active. Okay. Yeah. So that's it. Yeah, so thank you guys for watching, and I'll see you guys next time.